This morning, as I was watching Third Eye Drops on YouTube, I was reminded about how much I really enjoy hearing Lawrence Hillman speak. His philosophy blends together so many interesting facets of what I'm trying to talk about here. He's quite embedded in archetypal psychology, which makes sense. His father was Dr. James Hillman, the father of archetypal psychology and author of The Soul's Code, among many other books. But in his own right, he approaches this subject with such a beautiful, well rounded view that doesn't neglect to consider quantum physics. In the episode that I watched recently, he even touched on what is really the topic of today's chapter here on Yellow Brick Road Rash: the interconnectedness of all things. I really want a copy of his book titled Archetypes at Work, but it's very hard to find. I'm sure it's meant for those working in the field of psychology, but I'm intrigued by his approach. I'm attaching a link to his webpage for you to peruse. He is also a master astrologist. How cool is that? I love any place that combines science with things we call metaphysics. But as I think you will see, or I hope you will see by the end of this chapter, if everything derives from one source, then science and metaphysics come from the same source as well. But I'm getting ahead of myself. Where I left off in the last chapter, I discussed Dr. Pribram's amazing theories about holograms and how understanding them helps us also understand aspects of brain function. At the end, I spoke briefly about how he met physicist Dr. David Bohm and had his ever-loving mind blown. In this chapter, we're going to discuss Dr. Bohm's ideas on how the concept of the hologram can be applied to everything in our known universe. I'm going to be doing a lot of direct quotes so I get the information correct, but it is important to reiterate here that these are complex subjects that we are having to define using language that is essentially a map, not the territory. Our language itself is too limited. Mathematical equations are the only way to thoroughly describe these scientific concepts. Math is the only language that tells us exactly what is happening. And as such, it is also important to say that theories are meant to be proved or disproved by experiments, peer review, and more importantly, mathematical equations. A theory takes time to prove, if it ever will be. Only the most solid theories are ever proven, and that's how we can be pretty sure they're true. But even then, in the context of time, as we learn about the bigger and bigger picture, things we thought were true can prove to be incomplete descriptions. Many of the concepts in this book still hold true as working theories today. I know this because I've heard parts of it mentioned by other newer, more contemporary, credible sources I follow. Speaking of math, I've always been in the camp that learning upper levels of math in high school were a waste of time. I mean, I was going to be an artist. Why did I need math? But now I understand that it is a language, and anyone with the ability to learn and write that language has the power to know about our universe. Not everyone will be able to do that kind of math. I think I could have if I'd been given the idea of how powerful and beautiful that is. We have to try to also understand that the new way of learning math will help future generations to that end goal, not just describing code for computers, but also describing the universe by making sense of what permeates through all of existence. I just adored this book, so much so that I bought a first edition hardback copy. It was the first time I could see the point of convergence, that place where science and spirituality begin to come together. I could feel it so deeply. I had almost zero people to talk to about it, and I'm hoping that what I share here grabs your attention enough that you decide to read the book yourself. Even if you don't, but find the general concepts appealing, we can chat about it through the Yellow Brick Road Rash Discord server you can access through my Patreon account. The link is in the show notes, but you can also comment here. I would actually love to build a community there where we can chat about things. So join me. This chapter opens with a quote. One can't help but be astonished at the degree to which Bohm has been able to break out of the tight molds of scientific conditioning and stand alone with a completely new and literally vast idea, one which has both internal consistency and the logical power to explain widely diverging phenomena of physical experience from an entirely unexpected point of view. It is a theory which is so intuitively satisfying that many people have felt that if the universe is not the way Bohm describes it, it ought to be. This is by John P. Briggs and F. David Peat in The Looking Glass Universe. Bohm seemed to be able to leave convention behind and stretch himself into thought experience that allowed him to have these amazing and productive aha moments. But is that a key here? Is bracketing not only necessary to learn about things outside your comfort zone, but also necessary for making space for aha moments? Put another way, you have to be open to be able to receive insights, or some call them downloads. When was the last time you had an aha moment, deep insight, or download? Let me know in the comments. Bohm said, and I quote, "It is far more dangerous to adhere to illusion than face fact." I couldn't agree more, but sometimes facing the facts are difficult, so get out those mental brackets and let's move forward a bit. From the book, and I quote, "What made this new world of quantum physics so intriguing was that everything about it appeared to be so contrary to common sense. It seemed more like a land ruled by sorcery than an extension of the natural world, an Alice in Wonderland realm in which mystifying forces were the norm, and everything logical had been turned on its ear. One startling discovery was that if you split matter into smaller and smaller pieces, you eventually reach a point where those pieces, electrons, protons, and so on, no longer possess the traits of objects. And although an electron can sometimes behave as if it were a compact little particle, they have found that it literally possesses no dimension. This is difficult for us to imagine because everything at our own level of existence possesses dimension. And yet, if you try to measure the width of an electron, you will discover it's an impossible task, and an electron is simply not an object as we know it. I don't know about you, but that isn't what I learned about electrons, even in college in the mid-90s. Another quote from the book. Another discovery made is that an electron can manifest as either a particle or a wave. This chameleon-like ability is common to all subatomic particles. It is also common to all things once thought to manifest exclusively as waves, such as light waves, gamma rays, radio waves, X-rays. All can change from waves to particles and back again. The phenomenon should not be classified solely as either waves or particles, but as a single category of something that are always somehow both. And these some things are called quanta, and physicists believe they are the basic stuff from which the entire universe is made of. Quantum is singular, and quanta is plural. Referring back to Pribram's work on quantum holography and how the brain works, take this into consideration. Danish physicist Niels Bohr points out that if subatomic particles only come into existence as matter once observed, then it is also meaningless to speak of a particle's properties and characteristics as existing before they're observed. This was disturbing to many physicists, for physics, as we know it, was based on discovering the properties of phenomenon or measurable events. But if observation actually created such properties, what did that imply about the future of physics? Hence the modern advent of modern quantum physics. Einstein was extremely troubled by Bohr's assertions. He found Bohr's conclusion particularly objectionable because when combined with another of quantum physics findings, non-locality, it implied that subatomic particles were interconnected in a way Einstein simply didn't believe was possible. What? Einstein didn't agree? I think even he probably needed to learn some bracketing skills. Is that heresy? In trying to explain the most important concepts I'm going to leave out some details about how quanta, such as photons, are formed. But it involves the creation of twin particles, if you will. And according to quantum physics, no matter how far apart these particles, and in this case photons, travel when they're measured, they will always be found to behave identically, as if, like twins, they are copying each other's behavior. But they do it instantaneously. This is called entanglement and is a fundamental concept to modern quantum physics now. Important concepts to remember in a nutshell. So the prevailing theory of the time was that physicists believed subatomic particles could turn into waves and then back into particles again once observed. And emerging quantum science was also saying that twin subatomic particles that traveled infinite distances apart could copy each other instantaneously. This was coined crazy action at a distance. But Einstein, along with his colleagues Boris Podolsky and Nathan Rosen, firmly disagreed with the supposition that twin particles could instantaneously communicate with each other, no matter how far apart they were. Remember, though, this was being postulated in the mid to late 20th century. For it to be true, the speed of light would have to be exceeded, which violated Einstein's law of special relativity. The colleagues were convinced that no reasonable definition of reality would permit such faster-than-light interconnections to exist, and therefore Bohr had to be wrong. Their argument is now known as the Einstein-Podolsky-Rosen paradox, or EPR paradox. Bohm was unperturbed by Einstein's argument. Einstein was basing his argument on an error when he viewed twin particles as separate, when they were actually part of that one indivisible system I spoke about earlier, that one fundamental source, and it was meaningless to think of them as otherwise. Bohr's view that subatomic systems are indivisible has equally profound implications for the nature of reality. Clearly, Bohm assumed that particles such as electrons do exist in the absence of observers. He also assumed that there was an even deeper reality beyond quantum, at a subquantum level. He discovered that simply by proposing the existence of a new kind of field on this subquantum level, he was able to explain the findings of quantum physics as well as Bohr had. Bohm called this proposed new field the quantum potential and theorized that, like gravity, it pervaded all of space. However, unlike gravitational fields, magnetic fields, and so on, its influence did not diminish with distance, which sounds like non-locality and entanglement to me. Bohm continued to refine his alternative approach to quantum physics. Classical science had always viewed the state of a system as a whole as merely the result of the interaction of its parts. However, the quantum potential stood this view on its ear and indicated that the behavior of the parts was actually organized by that one source, that one whole. This not only took Bohr's assertion that subatomic particles are not independent things, but were part of an indivisible system, one step further, but even suggested that wholeness was in some ways the more fundamental primary reality. An even more surprising feature of the quantum potential was its implications for the nature of location, or locality, at the level of our everyday lives. Things have very specific locations in this dimension, but Bohm's interpretation of quantum physics indicated that at the subquantum level, the level in which quantum potential operated, location ceased to exist. All points in space became equal to all other points in space, and it was meaningless to speak of anything as being separate from anything else. This non-local aspect of the quantum potential enabled Bohm to explain the connection between twin particles without violating Einstein's special relativity's ban against anything traveling faster than the speed of light. To illustrate, he offers the following analogy. Imagine a fish swimming in an aquarium. Imagine also that you have never seen a fish or an aquarium before, and your only knowledge about them comes from two television cameras, one directed at the aquarium's front and the other at its side. When you look at the two television monitors, you might mistakenly assume that the fish on the screens are separate entities. After all, because the cameras are set at different angles, each of the images will be slightly different. But as you continue to watch, you will eventually realize there is a relationship between the two fish. When one turns, the other makes a slightly different corresponding turn. When one faces the front, the other faces the side, and so on. If you are unaware of the full scope of the situation, you might wrongly conclude that the fish are instantaneously communicating with one another, but this is not the case. No communication is taking place because at a deeper level of reality, the reality of the aquarium, the two fish are actually one and the same. That's a pretty cool analogy. This, says Bohm, is precisely what's going on when twin photons are emitted, because the quantum potential permeates all of space. All particles are non-locally connected. The only problem at this point was that it required a level of technology and precision that was not yet available. To test that particles such as those in the EPR paradox were not using some normal means of communication, the basic operations of the experiment had to be performed in such a brief instant that there wouldn't be enough time for a ray of light to cross the distance separating the two particles. This meant that the instruments used in the experiment had to perform all of the necessary operations within a few thousand millionths of a second. Okay, now I'll take you back to holograms. In the 1960s, Bohm turned his attention to looking at order. Classical science generally divides things into two categories: those that possess order in the arrangement of their parts, and those whose parts are disordered. A random snowflake in computers are ordered. The pattern of a handful of spilled coffee beans on the floor is disordered. Bohm realized there were also different degrees of order, though, and this implied that there was perhaps no end to the hierarchy of order that existed in the universe. From this, what occurred to Bohm was that maybe things that we perceive as disordered aren't disordered at all. Perhaps their order is at such an indefinitely high degree that they only appear to us as random. In other words, something that appears disordered actually has order if you back up far enough to see it. After contemplating the concept of order, Bohm went on to describe it as being either visible or measurable, known here as explicit order, or invisible, unmeasurable, implicate order, and he encountered an excellent metaphor for understanding it, one that enabled him not only to bring together all the various strands of his years of thinking, but did so with such force and beauty it seemed almost tailor-made for the purpose. That metaphor was the hologram. As soon as Bohm began to reflect on the hologram, he saw that it provided a new way of understanding order. The interference patterns recorded on a piece of holographic film, like we've described, appeared disordered to the naked eye. It possessed an implicate order that is hidden or unfolded, while the actual hologram represented the explicit or visual order. But this was not the only insight the hologram provided. The more Bohm thought about it, the more convinced he became that the universe actually employed holographic principles, and its operations was itself a kind of giant flowing hologram. And this realization allowed him to crystallize all of his various thoughts into a sweeping and cohesive whole. In 1980, he presented a mature distillation of his thoughts in a book entitled Wholeness and the Implicate Order. In it, he did more than just link his various ideas together. He transfigured them into a new way of looking at reality that was as breathtaking as it was radical. One of his most startling assertions is that the tangible reality of our everyday lives is really a kind of illusion, like a holographic image. Underlying it is a deeper order of existence, a vast and more primary level of reality that gives birth to all the objects and appearances of our physical world. in the same way that a piece of holographic film gives birth to a hologram. Bohm calls it a deeper level of reality, the implicate, which means enfolded order, and he refers to our own level of existence as the explicate or unfolded order. He sees the universe as the result of countless enfoldings and unfoldings between these two orders. Bohm believes that an electron is not one thing, but a totality or ensemble enfolded throughout the whole of space. When an instrument detects the presence of a single electron, it is simply because one aspect of the electron's ensemble has unfolded. A piece of holographic film and the image it generates are excellent examples of implicate and explicate orders. The film is an implicate order because the image coded in its interference patterns is a hidden totality enfolded through the whole. The hologram projected from the film is an explicate order because it represents the unfolded and perceptible version of the image. Stay with me here. The constant flowing exchange between the two orders explains how a quantum can manifest as either a particle or a wave. The way an observer interacts with the ensemble determines which aspect unfolds and which remains hidden. As such, the role an observer plays in determining the form a quantum takes may be no more mysterious than the fact that the way a jeweler manipulates a gem determines which of its facets may be visible. Because the term hologram usually refers to an image that is static and does not convey the dynamic and active nature of the incalculable foldings and unfoldings that moment by moment create our universe, Bohm prefers to describe the universe not as a hologram, but as a hollow movement. The existence of a deeper organized order also explains why reality becomes non-local at the subquantum level. When something is organized holographically, all semblance of location breaks down. Saying that every part of a piece of a holographic film contains all of the information possessed by the whole is really just another way of saying that the information is distributed non-locally. Hence, if the universe is organized according to holographic principles, it too would be expected to have non-local properties. Most mind-boggling of all of Bohm's fully developed ideas about wholeness, because everything in the cosmos is made out of the seamless holographic fabric of the implicate order, he believes it is meaningless to view the universe as being composed of parts. It's as meaningless as it is to view the different geysers as separate from the water out of which they flow. An electron is not an elementary particle. It is just a name given to a certain aspect of the hollow movement. Dividing reality up into parts and then naming those parts is always arbitrary. A productive convention because subatomic particles and everything else in the universe are no more separate from one another than the different patterns in an ornate carpet. This is a profound suggestion, as you can imagine. Despite the apparent separateness of things, at the explicate level, everything is a seamless extension of everything else, and ultimately even the implicate and explicate orders blend into each other. Take a moment to consider this. Look at your hand. Now look at the light streaming from the lamp beside you and the dog resting at your feet. You're not merely made of the same things. You are the same thing, one thing, unbroken, one enormous something that has extended its uncountable arms and appendages into all the apparent objects, atoms, oceans, and twinkling stars in the cosmos. Bohm cautions, though, that this doesn't mean the universe is a giant and undifferentiated mass. Things can be part of an undivided whole and still possess their own unique qualities. To illustrate what he means, he points to the little eddies and whirlpools that often form in a river. At a glance, such eddies appear to be separate things and possess many individual characteristics, such as size, rate, and direction of rotation. But careful scrutiny reveals that it is impossible to determine where any given whirlpool ends and the river begins. Bohm believes that our universal tendency to fragment the world and ignore the dynamic and interconnectedness of all things is responsible for many of our problems, not only in science, but in our lives and our society as well. We believe we can extract the valuable parts of the earth without affecting the whole. We believe it is possible to treat parts of our body and not be concerned with the whole. We believe that we can deal with various problems in our society, such as crime, poverty, and drug addiction, without addressing the problems in our society as a whole, and so on. In his writings, Bohm argues passionately that our current way of fragmenting the world into parts not only doesn't work, but may even lead to extinction. This is super important in today's age. Bohm's holographic universe explains many other puzzles, like what is the effect consciousness seems to have on the subatomic world. As we have seen, Bohm rejects the idea that particles don't exist until they are observed, but he is not in principle against trying to bring consciousness and physics together. He just thinks that most physicists go about it the wrong way, by once again trying to fragment reality and saying that one separate thing, consciousness, interacts with another separate thing, a subatomic particle. Because all such things are aspects of the hollow movement, he feels it has no meaning to speak of consciousness and matter as interacting. In a sense, the observer is the observed. The observer is also the measuring device, the experimental results, the lab, the breeze that blows outside the lab, etc. He believes that consciousness is a more subtle form of matter, and the basis for any relationship between the two lies not in our own level of reality, but deep in the implicate order. Consciousness is present in various degrees of enfoldment and unfoldment, and in all matter. As Bohm puts it, the ability of form to be active is the most characteristic feature of a mind, and we have something that is mind-like already with the electron. He believes that dividing the universe between living and non-living things also has no meaning, and inanimate matter are inseparably interwoven, and life too is folded throughout the totality of the universe. Even a rock is in some way alive, says Bohm, for life and intelligence are present, but not only in matter, in energy, space, the fabric of everything in the universe, everything we extract out of the hollow movement. And we mistakenly view them as separate things. The idea that consciousness and life, and indeed all things, are ensembles and folded throughout the universe has an equally dazzling flip side. Just as every portion of a hologram contains the image of the whole, every portion of the universe enfolds the whole. This means that if we knew how to access it, we could find the Andromeda galaxy in the thumbnail of our left hand. Every cell in our body enfolds the entire cosmos. So does every leaf, every raindrop, and every dust mite, which gives new meaning to William Blake's famous poem, "To see a world in a grain of sand and a heaven in a wildflower. Hold infinity in the palm of your hand and eternity in an hour." If our universe is only a pale shadow of a deeper order, what else lies hidden or unfolded in the warp and weft of our reality? Bohm believes that according to our current understanding of physics, every region of space is awash with different kinds of fields, composed of waves of varying lengths. Each wave always has at least some energy. When physicists calculate the minimum amount of energy a wave can possess, they find that every cubic centimeter of empty space contains more energy than the total energy of all the matter in the known universe. That is insane. And this is an incredible thought. Some physicists refuse to take this calculation seriously. But Bohm says, like fish unaware of the water in which they swim, these physicists have been taught to focus primarily on objects embedded in the ocean. He ponders that space is as real and rich with processes as the matter that moves through it. This concept reaches full maturity in his ideas about the implicate sea of energy. Matter does not exist independently from that sea, from so-called empty space. It is a part of space. To explain what he means, he offers this analogy. A crystal cooled to the absolute zero will allow a stream of electrons to pass right through it without scattering them. If the temperature of that crystal is raised, various flaws in the crystal will lose their transparency and begin to scatter those electrons. From an electron's point of view, such flaws would appear as pieces of matter floating in the sea to the electron. But this is not the case. The nothingness and then the pieces of matter do not exist independently from each other. They are both of the same fabric, the deeper order of the crystal. Bohm believes that the same is true at our own level of existence. Space is not empty, it is full, and it is the ground for the existence of everything, including ourselves. The universe is not separate from this cosmic sea of energy. It is just a ripple on its surface, a comparatively small pattern of citation in the midst of an unimaginably vast ocean. This excitation pattern is relatively autonomous and gives rise to approximate, recurrent, stable, and separable projections into a three-dimensional explicit order of manifestation. In other words, despite its apparent materiality and enormous size, the universe does not exist in and of itself, but is the stepchild of something far vaster and far more inevitable. More than that, it is not even a major production of this vaster something, but it's only a passing shadow, a hiccup in the greater scheme of things. This infinite energy is not all that is enfolded in the implicate order. Because the implicate order is the foundation that is giving birth to everything in our universe, at the very least, it also contains every subatomic particle that has been or will be, every configuration of matter, energy, life, and consciousness that is possible, from quasars to the brain of Shakespeare, from the double helix to the forces that control the sizes and shapes of galaxies. And even this is not all it may contain. He concedes that there is no reason to believe the implicate order is the end of things. There may be even other unrealized layers of order beyond it, infinite stages of further development. A number of tantalizing findings in physics suggest that Bohm may be correct. Space is filled with light and other electromagnetic waves that constantly are crisscrossing, interfering with each other, as we have seen. All particles are also waves. This means that physical objects and everything else we perceive in reality are composed of interference patterns. In fact, that has undeniable holographic implications. There are physicists who are skeptical, but there are also physicists who are sympathetic to his ideas, including such big guns as Roger Penrose of Oxford, the creator of the modern theory of the black hole, Bernard Dean of the University of Paris, one of the world's leading authorities on the conceptual foundations of quantum theory, and at Cambridge is Brian Josephson, winner of the 1973 Nobel Prize in Physics. Josephson believes Bohm's implicate order may someday even lead to the inclusion of God or mind within the framework of science, an idea that Josephson supports, and quite frankly, I do too. Considered together, Bohm and Pribram's theories provide a profound new way of looking at the world. Our brains mathematically construct objective reality by interpreting frequencies that are ultimately projections from another dimension, a deeper order of existence that is beyond both space and time. The brain is a hologram, enfolded in a holographic universe. For Pribram, this synthesis made him realize that the objective world does not exist, at least not in the way we are accustomed to believing it does. There is a vast ocean of waves and frequencies, and reality looks concrete only to us because our brains are able to take this holographic blur and convert it into the sticks and stones and other familiar objects that make up our world. How is the brain able to take something as insubstantial as a blur of frequencies and make it seem solid to the touch? The kind of mathematical process that Bekesi simulated with his vibrators is basic to how our brains construct our image of the world out there. In other words, the smoothness of a piece of china and the feel of the beach sand beneath our feet are really just elaborate versions of the phantom limb syndrome. Bam. This does not mean there aren't china cups and grains of beach sand out there. It simply means that they have two very disparate aspects to their reality when it's filtered through the lens of our brain. But if we could get rid of our lenses, we'd experience it as an interference pattern. Which one is real and which one is illusion? Both are real to me, says Program, or if you want to say, neither one of them are real. But don't be troubled if this is difficult to grasp. It is relatively easy to understand the difference between something internal and something that is external to us, like an apple or a hologram. What makes it difficult is that in this case, we are not looking at the hologram. We are part of the hologram. The difficulty is also another indication of how radical a revision Bohm and Pribram are trying to make in our way of thinking. But it is not the only radical revision. Pribram's assertion that our brains construct objects, plus Bohm's conclusions that we then construct space and time, are just one of the subjects that will be examined as we explore the effect Bohm and Pribram's ideas have had on the work of researchers in other fields. Wow. So what do you think? When I first read the book, I was enthralled by all of this information coming from what was outside my own admittedly limited human experience, and I became fascinated by the potential of it all. But it helped me have clarity on a couple of things right off the bat. First of all, if part of what it means to be alive has to do with interpreting interference patterns, we are at minimum a very long way from training robots to do so. We don't even know how it all works yet. But even if we can eventually train them to read interference patterns, they still cannot go back to source at the same level we do. I believe sentience requires not only existing in this dimension and being able to interpret those patterns, but also one needs to have metabolism and a certain level of awareness. But we are unique in that we have awareness of our own self-awareness. We will elaborate more on this in future episodes. If we are all connected to Source, that means at a fundamental level we are all one, and that does include all animate and inanimate things, because they all are made with the subatomic particles that join us to Source. But as was mentioned in this chapter, if we are all one, then we do have a responsibility to each other and to our environment. Because surely, if Bohm is right, Source cannot be healthy if we are hurting each other. So that leads me to some facets of the Wizard of Oz that aren't really discussed. I, for one, never liked the scene where Dorothy picks an apple from the tree. I remember feeling jolted by the idea that that tree cared about being picked, even in a make-believe world, because it just wasn't like that in reality. But reading the Holographic Universe has made me begin questioning how I interact with everything from cows to mice to stinging nettle. I mean, I inherently knew that an ecosystem has to maintain balance to function optimally, but what happens when you shift your intention towards the understanding that how we interact with everything in our known and measurable world actually matters? But I also thought it was funny that she could be open to the idea of a talking scarecrow, but not necessarily a talking tree. She just seems so shocked, but maybe she was just hangry. I think that's what it was. As I mentioned before, Baum had become a theosophist, and Rudolf Steiner's work with biodynamics, for example, is very grounded in naturalist philosophy. So I can imagine that scene having a great deal of intentional messaging attached to it. But maybe it is just taking almost 100 years after the movie was released for us to get it. Another more recent movie where I was struck by this same concept was the very first Avatar movie, when the human soldier shot the animal in the forest and the woman prayed over it in such a beautiful way, acknowledging life as an important part of the whole and thanking it for its sacrifice. In many traditions, prayer before meals is supposed to be exactly this. But somehow growing up, I never felt it like I did when I saw that scene. Something to think about, honoring that sacrifice in a more significant way. Maybe in the end, there is a modern lesson to be learned here. A couple of years ago, I read about studies being done that proved plants respond to music. I remember hearing this many years ago, growing up, that plants seemed to love music and actually grew better. But now they have proved it by attaching electrodes to plants and measuring their responses. I think it's exciting that technology is providing us with measurable ways to observe our world, thereby help us reframe what it is like to be alive here on this planet that is so full of life and apparently consciousness on a level we never thought possible does exist. If consciousness permeates everything, but at different levels, and if every particle contains all the information of the universe, and we are all part of one whole source, then what kind of bracketing do we need to do to allow space for realizing how we treat not only each other, but our earth and all creatures on it matters? What is the end result if this is correct and we don't figure it out? Will it lead to our destruction? I will close this video by mentioning our heroes' arrival in the Emerald City and the warm welcome they received by the people once they realized Dorothy was the chosen one. Although in retrospect, it feels like they were kind of pigs being led to slaughter, aka being prepared for sacrificial ritual. If I stick to the theme of today's chapter, our oneness, I'm going to leave you with the thought that perhaps the people of the Emerald City were just setting the table for the strangers to their land. They extended a helping hand and literally washed their feet. Okay, that's the end of today's chapter. I hope you enjoyed it. I know it's a lot of information and it might not be something you can absorb all at once. Please go back and watch it over and over to contemplate all that it is sharing with us. And if you have any questions, then please write me in the comments or please join my Patreon. My minimum membership level is literally $2. And that will give you access to my Discord server, which I haven't fully figured out yet. I am 62 years old trying to figure out all this technology simultaneously, so forgive me if I'm slow at it. But I really, really want to be able to connect with you guys there. So consider joining my Patreon. But that's it for today. Thank you for joining me. Please like, share, subscribe to my channel. I'd appreciate it. Bye-bye.